Today we start Unit 2 by working on solving percent problems from Chapter 10, Section 1. Now hopefully you notice that there is a link to several different videos online, YouTube videos that talk about solving percents. So please feel free to go through and watch those and look at those approaches, how they might be different from the way I present it. Also, there are the MyMathLab videos. Those are going to be a little bit different than what I present. There's more than one approach to almost everything you want to do in math. So when we talk about a percent, we're talking about a ratio of some number compared to 100. A ratio of some number compared to 100. Now, that's why we call it percent, because percent literally means per 100. Now, giving something as a percentage makes it a lot easier to talk about and to understand how it relates to us. We are in the summer of 2020 right now while we're doing this video, and the pandemic is raging. We're waiting to see if there's going to be a second wave. When it first started and we started seeing direct comparisons with numbers to other countries, it really frustrated me because, for example, they were comparing where we were directly with numbers to Italy and saying that we were in just as bad a place. Well, that doesn't work because our population is 6 times that of Italy. So while our numbers might have been very close to the same, those raw numbers, the percentages were vastly different. You can't look at just raw numbers and get a good sense of what is going on. For example, if I told you that we had 2 different hospitals and each of the hospitals had noted 10 different times the wrong dose of medication were given in the last month. Well, that sounds like they have the same incident rate. But then if I come back and tell you that one hospital is a tiny 50-bed hospital and the other hospital is a 500-bed hospital, well, suddenly that 10 incidents is much bigger for the small hospital than it is for the larger hospital. So instead of using raw numbers, raw data, we like to use percentages and take it out of 100. If I say that something is 15 out of 100, that's the same as saying I have 15%. If I'm looking for general terms, that means that I'm going to put it as x over 100 is going to give me x%. Okay, to switch back and forth from a fraction to a percent, you're going to divide the fraction first. Remember that a fraction bar is just a division symbol. So if I want to change from a fraction to a percent, I'm going to divide the fraction, and then I multiply that by 100%, basically. I multiply by 100 and add that percentage sign. So if I think about multiplying it by 100%, that moves we move from a fraction to a decimal, and when we do this step, we move that decimal to a percentage. When I multiply by 100%, that moves my decimal place 2 places to the right, and it adds in my percent sign. Let's do an example here, and I'll show you on your calculator. Usually we are going to have to round these off, and MyMathLab will give you rounding instructions. So if I give you 15 out of 17, that's going to be less than 1 whole because the numerator, the top number, is smaller than the denominator, the bottom number. The bottom number, my denominator, tells me it takes 17 pieces to make 1 whole, and I have 15 out of those 17. So I have almost 1 whole, but not quite. In my calculator, I'm going to enter 15, choose divided by as my fraction bar, that's division, 17 is, and I get this decimal that continues, it doesn't repeat, it just keeps going, and I ran out of room. So my calculator has already rounded off this decimal. We're going to round it to, let's say, 4 decimal places when we write it down. So I'm going to change my equal sign to an approximate sign. A wavy equal sign means it's not exact. I have rounded it off. 0.882. And when I round that 4th decimal place, 1, 2, 3, 4. The 3 is in the 4th decimal place. This is the place I want to round. So I'm rounding this decimal place. I look to the right and I see I have a 5. Well, our number system is base 10. That means that 5 is halfway to the next value. If I am at 5 or bigger, I am at least halfway there to the next value up. So I'm going to round up. So when I round to this 4th decimal place, I look to the right, I've got a 5 there. That means I'm going to round this 3 up to a 4. You're going to notice that on MyMathLab, they need you to round correctly. So you do need to pay attention to that. I've changed my fraction to a decimal. I don't want to leave it as a decimal. I want a percentage. The way I change that decimal to a percent is to multiply by 100%. That gets my percent symbol there, and it moves my decimal 2 places to the right. So when I have fraction to decimal, I know I need to move that decimal 2 places to the right and add my percent sign. That means my percentage would be 88.24%. When I multiply by that 100%, the whole purpose of that is to move my decimal 2 places to the right, because when I do the division, I get a decimal. I want it out of 100, so that it would be out of 100. Okay. Changing decimal to percent. That is this piece right here. So we went from fraction to percent. We did 2 steps. Decimal to percent is just that 1 step. To change a decimal to percent, we just multiply by that 100%. That action, multiplying by 100%, moves our decimal 2 places to the right. So that if I started with a decimal, let's say I start with 0.23, that is the same thing as 23%, because if I multiply that by 100%, I move my decimal 2 places to the right and I add my percent sign. Let's say I start with 1.07. Well, if I change that to a percent, I multiply by 100, it moves that decimal 2 places to the right, and I have 107%. What if I had something really small? What if I had 0.00035? Well, when I change that to a percent, I'm still just moving my decimal 2 places. 1, 2 puts the decimal here, so that I would have 0.035%. Notice that my percentage can be tiny, or it can be more than 100. I can have more than 100%. Now, I can't eat more than 100% of the pizza, and I can spend more than 100% of my money. If I have credit, I can go into debt, right? But I can have more than 100% increase in something. So let's say that I was working part-time and then I got a better job and it was full-time. Well, I could have more than 100% increase in salary because suddenly I'm working more and I'm getting paid better. So if I was making $10 an hour, now suddenly I'm making $15 or $25 an hour. That's more than 100% increase. So it is possible to have more than 100%. Okay, let's look at the next one. We're changing from percent to decimal. When we went from decimal to percent, we multiplied by 100%. If we're going back the other direction, we do the inverse operation. What operation undoes multiplication? Well, division. So now I'm going to divide by 100%. That, instead of moving my decimal 2 places to the right, now it moves my decimal 2 places to the left. It's going to move my decimal 2 places to the left. So think about this. For these three examples, we went decimal to percent, and the decimal moved 2 places to the right, so the number got bigger. You see that? We went from 0.23 to 23, from 1.07 to 107, from, let's see, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, from 35 thousandths to 35 thousandths. So my number gets bigger when I go from decimal to percent because I'm multiplying by 100. However, when I go the other direction and I'm dividing by 100 to go from percent to decimal, if I have 25%, when I divide that by 100, it ends up being 0.25. When I divide, because I'm dividing by 100%, that percent sign also divides out. If I had 234%, when I divide that by 100%, my decimal moves back 2 places to the left and I have 2.34. Okay, so those are a couple of examples moving from percent to decimal. Let's talk about our percent proportion. There are 2 different ways to approach a percent problem, 2 basic ways. One is to interpret the words and put them in an equation form. The other way is to use the percent proportion. When I solve a problem using the percent proportion, I'm comparing part to whole, and then I have the percent out of 100. So the percent is still the part to whole, basically, but this ratio is the percent out of 100. This allows me to start with a problem and solve to figure out what the percentage would be. Now, I want to point out, we can have more than 100%. We can have, over here we have 107%, here we have 234%. If I have 107 over 100, that means the top, the numerator, the part is greater than the whole. And so if the part is greater than the whole over here, if I have more than 100%, then the part is going to be greater than the whole over here. I will have an improper fraction where the numerator is bigger than the denominator. That can happen. So when you're reading your problem, you cannot just say, oh, this number is smaller, it must go in the numerator. You have to pay attention to what the values are. Let's say that let's do an example of a percent proportion to solve. Let's say that we have 3/7 and we want to know what percentage that is. Well, I have my fraction and I have a way to solve that up here. I could do the division and then multiply by 100%, but we're going to practice by setting it up as a percent proportion. I'm given 3/7. I don't know what the percent is, so that's my missing piece. So I do know, therefore, according to my percent proportion, that 3/7 is going to be equal to something out of 100. And I'm trying to figure out what that something is that represents my percentage. You solve a proportion by finding cross products and setting them equal to each other. So cross products means I multiply one numerator by the other denominator. When I find my cross products here, I have 3 times 100. That gives me 300, and that is going to be equal to 7x. So I have 300 equals 7x. Well, how do I finish solving for x? I'm going to divide by that 7. This is 7 times x. The inverse or opposite operation is division. So I'm dividing both sides by 7. When I divide by 7, anything over itself is just 1. So that leaves me with x on the right side of my equation. And x is equal to whatever 300 divided by 7 is. Now, before we plug that into our calculator, I want to point out to you that if I took 3/7 and then multiplied it by 100, that's what I would get, would be 300 over 7. So my percent proportion ends up being the same steps as changing from a fraction to a percent. Okay, plug 300 divided by 7 into your calculator. When I do that, 300 divided by 7, I get 42 and then I get this long decimal. So we are going to have to round it off. Let's round to 1 decimal place. So that would be 42 point, well, I need to round that 8, so I look to the right, and I'm halfway there, which means I round up. So this rounds to, I'm going to change that to approximately 42.9%. So 3/7 is about 42.9%, which if you think about it makes sense because 3 is just a little bit less than half of 7. 42, almost 43 is a little bit less than half of 100%. The last major topic that we discuss in 10.1 is percent increase and percent decrease. With percent increase and percent decrease, the first thing you need to do is figure out what the change is. So you're going to find the increase or decrease. Either the cost of something went up or it went down. The number of available time slots went up or they went down. So you're going to figure out by how many. That is what we use as the part, or the numerator of our fraction. Then I'm going to compare that to the original, which means I'm going to divide, because the original is going to be the whole. And finally, I multiply by 100%. Okay, so we are going to do, you know what, I will come up with an example of a percent increase or decrease problem. Let's say that when we went on lockdown, the number of hours you were offered at work went from, so hours at work went from 30 to 12. So instead of working 30 hours a week, now I'm working 12 hours a week. What percentage did your work decrease by? So what's your percent decrease in the number of hours you're working? Well, first you have to find the difference. You find the actual decrease. So if I was working 30 hours and now I'm working 12, I figure out what that difference is. 30 minus 12 gives me 18 hours decrease. So when I set up my problem, I put that part over the whole, the original, what I started with. So I decreased by 18 hours. I was originally working 30 hours a week. And then I'm going to multiply that by 100%. So use your calculator to do 18 divided by 30. 18 divided by 30. And I get 0.6. So 0.6 times 100%. I take that 0.6, I change it to a percentage. That means I move the decimal 2 places, and I had a 60% decrease in my work hours. So that's a percent decrease problem. Okay, the next few pages, lots and lots of practice. Some of it you should be able to not use a calculator. For example, this next page, numbers 1 through 12, you should be able to not use a calculator by reasoning through these. Let's talk through these together. Set your calculator aside. I do want to encourage you to, if you feel like you have a pretty decent grasp on percents, read through these 12 first on your own. See what you know. See what you can figure out, again, without your calculator. This is some mental math practice. And write down what you think the answer is, and then come back to the video and we'll go through them. All right, you leave an $18 tip for a restaurant bill of $100. What percent tip did you leave? Well, remember that percent is out of 100. So since our bill is 100, that makes it really easy. If I'm leaving an $18 tip on a $100 tab, well, that's 18 out of 100, which is just exactly 18%. All right, number 2, the tax on a $200 stereo is $12. What's the tax rate? Well, that is $12 on a $200 stereo. The dollar signs cancel out, dollars over dollars. So I've got 12 over 200. Remember, percent is out of 100, and those are both even numbers. I can reduce them both by 2. So 12 divided by 2 is 6, and 200 divided by 2 is 100. Anything compared to 100 is the same as the percentage. So my tax rate is 6%. On the next one, the cost of labor was $45 for every $100 spent. What percent is that? Well, again, that's out of 100, so that translates directly to a percentage. That would be 45%. 38 out of 50 planes departed on time. 38 out of 50. I need to make that something out of 100 to translate it directly to percentage. Well, what do I do to 50 to get 100? I multiply by 2. So 38 by 2 is 72. That is 72%. All right, now we're kind of thinking the other direction. What is 50% of 700? Well, 50% is half. So what's half of 700? Hopefully you can do that in your mind and come up with 350. 25% of $520. Well, 50% is half. What's 25%? What's 25 cents out of a dollar? We call a 25-cent piece a quarter because 25% is a quarter or a fourth, which means I can do 520 divided by 4 to figure out what is 25% of 520. Now this is kind of hard to look at, but I can do long division. 520 divided by 4. 4 goes into 5 one time, and that leaves me with 12. 4 goes into 12 3 times, and I've still got that 0 there. So 25% of $520 is $130. As you're doing these problems, make sure you're paying attention to when you need a dollar sign or when you need units. A team won 12 out of 18 games. What percentage did they win? Well, 18 isn't going to change to 100 very easily, but I can look at it and see about maybe reducing it. And I'm able to see that they're both divisible by 6 because I know my multiplication tables. But if I didn't know that, I would hopefully at least recognize that they're both even numbers, and I can divide them both by 2. Well, if I divide 12 by 2, I get 6, and 18 divided by 2 is 9. And then I can divide again. What factor do they have in common here? Well, they're both divisible by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. So a team won 2/3 of its games. Do you know what percentage 2/3 is? It's a common percentage. When we have 1/3, we say 33%. 2/3 is actually 0.666666 repeated, so we're going to round that to 67% because that would be 66.666, and that's going to round up to 67%. All right, our next problem says a family of 4 with a monthly income of $2,100 spent 90% of its earnings. How much did they spend? Well, if they spent 90%, how much did they save? 90% is just 10% away from 100, right? So they saved 10%. There is a quick way to find 10% of anything. If you were changing from a percentage back to a decimal, you would be dividing by 100, so you'd move it 2 places. When we just need 10% though, we just have 1 0. We're just going to move our decimal 1 place to the left. So you might write over here to the side that if you need 1%, let me start over and make it neater. If you need 1%, you move the decimal 1 place to the left. Two places to the left. Sorry. I got distracted. If you need 1%, you're going to move the decimal 2 places to the left. If you need 10%, move the decimal 1 place to the left. So if you need 2% or 1%, you move it 2 places to the left. If you move 10%, you just move it 1 place to the left. So if they saved 10% of their income, if I move that decimal 1 place, that means they saved $210. So how much did they spend? Well, they spent everything else. So I can take that 2,100, and subtract the 210. And I get 1890. So they spent $1,890. Okay. 550 is what percent out of 1,000? Well, remember that a percentage is out of 100, and it's pretty easy to simplify this. I can divide them both by 10, which means I'm going to cancel a 0 in the numerator and the denominator. That gives me 55 over 100, or 55%. 10% is how much of 100 years is, well, remember we talked about moving that decimal 1 place. So if I move my decimal 1 place there, I get 10 years. 21 combinations is what percent of 50 combinations? Well, that would be 21 out of 50, and we can easily make that out of 100 by multiplying by 2. 50 times 2 is 100. 21 times 2 is 42. And anything over 100 can be turned directly into a percentage. All right, this last one requires just a little bit of thought. How many customers is 125% of 88 customers? Well, 100% of 88 is the whole thing, so that would be 88. If I want 125%, I need 25%, not off, 25% of 88 to add to that. So 100% is the whole thing. 25% is a fourth. So I need to divide 88 by 4. 88 divided by 4 is going to be 22. So 100% plus 25% gives me 110 customers. And notice that we're using units. All right, that's our mental math. That's how we work through some of those problems. Let's do some where we need to use our calculator. Now, note that it says to show work. So anytime you are doing something where you're doing a written assignment for me, be sure that you prepare to show your work. When you show work, make sure you number it and you are organized and you mark your answer so that I can find it. If I get a page that needs work shown and you haven't shown your work, you won't get credit for those problems. All right. 336 students are what percent of 840 students? Now, there are different ways to approach this. We're going to use our percent proportion. 336 students are what percent? So what percent is my missing piece? That's X out of 100. I've got 336 students out of 840 students. So the 336 is the part, the 840 is the whole. And remember, I solved a percent proportion by finding cross products. So my next step would be 336 times 100, puts 2 zeros behind that, 3,600 now, is equal to 840 times X. And how do I solve for X? I'm multiplying, so I do the inverse operation, which means I divide by 840. And X is equal to whatever this value is, then turned into a percentage. Or no, that gives it to me as a percentage, actually, when I solve it this way. So I've got 33,600 divided by 840. That gives me 40%. When I set it up as a percent proportion, it gives me the answer as a percent. Okay. State sales tax is 7 3/4%. What would be the purchase price, or what would be the tax on a purchase of $85? So when I'm trying to find the percent, or the amount like that, I need to turn this percent into a decimal to work with it. I want to know what is 7 3/4% of $85. Well, I always translate of as times. So I change my percent to a decimal. What is 3/4 the same thing as? Well, 7 3/4% is the same thing as 7.75%. Just like 1/4 is 0.25, 3/4 is 0.75. If you have 3/4 of a dollar, you have 75 cents. So 7 3/4 is 7.75%. But when I work with it as part of a problem, I change it to a decimal. So when I change percent to a decimal, I move the decimal place back 2 places to the left, which gives me 0.0775. Of means to multiply. So I'm going to multiply that times 85. I type that into my calculator. So in my calculator, I have 0.0775 times 85, enter. And I get this amount. Now it's money, and we can only pay to the nearest penny. Penny is 2 decimal places. So I need to round my dollar figure to the nearest penny or the nearest hundredth. 2 decimal places. What unit is in the second decimal place? It's that 8. I look to the right and see that I'm going to need to round up. So this is approximately $6.59. That would be the tax on that purchase price. All right, 42% of 800 grams. How much of it is pure? Well, 42% of means to multiply. Remember that we turn our percent to a decimal. So I move that decimal 2 places back to the left, and I have 0.42 times 800. That's what I plug into my calculator. That's what I need written down to show. That comes out to be 336, and I'm going to use G for gram. Number 4, in an election, 68% of the 12,452 registered voters actually voted. How many people voted? We have 68% of this number. So when I work that problem, I change my 68% to a decimal, moves back 2 places to the left. Of means to multiply 12,452 people. When I plug that into my calculator, just like it looks, I get 8,467.36 people. Well, I can't have 0.36 people vote, so an exact answer does not make sense. So we are going to round that to the nearest whole person. When I round to the ones place, I look to the right. That's not at least 5. So it rounds to 8,467 people. Notice that for each of these, I'm using a unit. Percent, dollars, grams, people. I'm writing out how I work the problem, and then I'm boxing in my answer so that it's very clear. And if I want somebody to go back and look and check for partial credit, they can do so. All right. 1,190 miles is 140% of what number of miles? Now this can be set as a percent proportion, but it reads more easily to me as what I would call a percent equation. So we're going to interpret it as an equation, and then I'll show you how to set it up as a proportion. One thing that I want to make note of is that we have been given an amount that is 140% of an original number of miles, which means this is going to be more than what this is, because 140% is more than what I started with. It's more than 100%. Okay, we're going to work it as a percent equation. I have 1,190. Is means equal. Always. That word is means is equal to 140%. Let's go ahead and change that to a decimal. So that decimal would be 1.40 when I move it 2 places to the left. Remember, of means to multiply. And what number, well, what means we don't know. So that's my unknown. What I have is 1,190 is equal to 1.4 times x. I need to solve for x. How do I solve? I divide by 1.4. When I divide that, when I take 1,190 and divide it by 1.4, I get a total of 850 miles. X is 850 miles. Now, I promised I'd show you how to set that up as a proportion, so we're going to do that next. Well, we have a percent, so that percent side is 140 over 100%. We have to figure out, is this the part? Do we not know the part, or do we not know the whole? Remember, I'm told that this 1190 is the 140%. Well, if it is the 140, then it goes opposite the 140. And what we're looking for is that whole, or that original amount. And we should note that since our percentage is more than 100, this bottom number is going to be smaller than that top number. If you solve using the percent proportion, you get out the exact same answer as we got using the percent equation. Number 6. In number 6, we have 7.3% of $47 is how much? Well, I have that of, I'm going to use it as an equation and just multiply. I turn my percent to a decimal and I multiply it times $47. I'm using money, so I need to make sure that I round, if necessary, to the nearest penny when I plug that into my calculator. But I've showed you how to set up the problem and I've boxed my answer. Next, I have 207 employees is what percent of 59 employees? Well, what percent of 59? We're starting with 59, we end up with 207, so we expect much more than 100%. I'm going to set it up both ways. I'm going to set it up as an equation and then as a proportion. 207 employees is a keyword that means equal. What percent? That's what I don't know. That's x times 59, because of means to multiply. That's my equation I would solve. If I wanted to set it up as a proportion to solve, I'm looking for the percentage. So that's x over 100. Percent of the whole is 59. My part is 207, so I know I need more than 100%. If I choose to solve this way this time, that would give me 207 times 100 is 20700 equal to 59 times x. And if you look here, I'm almost the same thing. For both of these, I'm dividing by 59. When I divide by 59 with my proportion, I get that x is equal to, let's see, 20700 divided by 59 gives me 350, and I'm going to have to round that. Let's round it to the tenths place. I get 350.8% approximately. When I do it over here and I divide by 59, I get that x is equal to, if I do 207 divided by 59, notice that it gives me a decimal. It gives me 3.508. So when I solve the percent equation, I get the answer as a decimal, and I have to multiply it by 100% to turn it to a percentage. So that's one downside to using the percent equation. When I use the percent equation, I get the answer as a decimal and I still have to turn it into a percent. When I use the percent proportion, the answer I get out is a percentage. They're going to give me the same thing, but I have to stop and think. Now, that's why I need to evaluate whether or not I'm looking at a percent that is more or less than 100 from the very beginning so that I don't miss that step. Okay, I'm going to encourage you to pause your video and answer these remaining 4 questions on this page. And I'm going to put up the key while you're doing that so that you can check. So here are the results, the answers, how you set up those final 4 problems, and the answer that you should have gotten. Notice that you've got to pay very close attention to what is the part, what is the whole, what is it that I'm looking for. I set 8 and 9 up using the proportion. I set 10 up using the equation, and I did 11 using the proportion. Read your question carefully to make sure you know what you're looking for. If you have questions on these, I'm going to encourage you to contact me to talk you through them. Remember again, there are multiple videos listed that you can go look to for percent help. More percent practice. I want you to try to work through these again. I'm going to pause the video. I'm going to fill in the results and then let you look and compare and see how you did. All right. Here are the results for this page, 12 through 22. Make sure that you are setting up your problem correctly. Make sure you are reading it carefully so that you know what you are being asked for. Make sure that you are answering with units, that you are rounding appropriately. For example, number 17 asks for the number of magazines. Well, you can't have 0.7 or 0.6666 repeating parts of a magazine. So it makes sense to round it to the nearest whole magazine. There are the remaining answers. For example, number 22, you know that he's depositing 4.5%. That amount that he deposits is $146, which means that just has to be a small part of his monthly earnings. His monthly earnings are going to be significantly more than that. You need to make sure that the answer you get makes sense in the problem. So stop and read and apply these so that they make sense. We're going to go through the last page together. It's talking about percent increase and decrease, and it sets it up so that it tells you step by step what it is you're looking for. A business increased the number of phone lines from 4 to 9. So we're looking for a percent increase. We go from 4 to 9. So what is the change? The increase is going to be the part. Well, they added how many lines? They added 5 lines. And the whole is the original number. The whole, in this case, they started with 4 lines. To find the percent increase or decrease, we take that part to whole, or increase compared to the original, times 100%. And what I get out is 125% increase. On the second one, Tracy works as a massage therapist. During July, she cut her price. So we're looking for a percent decrease. And we need to find that decrease and compare it to the original. She cut the price on massages from $54 to $45.50. So how much did she knock off? Well, I need to subtract. And when I subtract, I find out that the price went down by $8.50. I'm going to compare that change to the original price of $54. So the problem I work out is $8.50 divided by 54 times 100%. And I discover that that was a 15.7% decrease in price. When you go to the store, a shirt normally costs $45. It's on sale. Well, if it's on sale, we're looking at a percent decrease. And we want to compare that decrease to the original amount. What's the change in price? I'm going to find the difference. 45 minus 27 means that it's $18 less than it was originally marked. I compare that change to the original, and I multiply by 100%. And I discover that it is a 40% off sale. Look at the next two, pause the video, see if you can figure out what the results should be. Okay, for number 4, we see that the UT tuition started at, in 2001, it was $4,226. And in 2012, 11 years later, it was $9,794. So it went up by $5,568. It doesn't say annual cost, so that's per year. hopefully you notice that the increase was more than the original amount. So you expect that your percent increase is going to be more than 100%. When you work the problem, you discover that it was in fact a 132% increase over 11 years. Those are realistic numbers, unfortunately. Okay, number 5, gross monthly income is how much you earn each month, but then they take out stuff, right? They take out taxes and Social Security and everything else, and what you net is the amount that actually goes into your bank account. So we are decreasing our salary, how much money we're making each month, and this person is decreasing. They're having $860 taken out of their original check. Well, how much is that? When I do the math, I come out with, whoops, not 210, but 21% decrease. So about almost a quarter of 21% of their income is being deducted.